Good morning. Appreciate the opportunity to be here today to talk to you about some of the challenges that we face as we design security into commercial microelectronics. The picture that I'd like to paint for you today is this kind of perfect storm that we face as security becomes ubiquitous. And I'd like to do that by trying to quantify 4 distinct areas. The first one is a common question that we ask our customers is, who's your adversary? And over the years, this question has elicited a lot of very interesting responses. And more recently, our commercial customers are describing their adversary as what I would call trending toward a nation state. And why is that? There's lots of good reasons. First off, a lot of the low-cost, sophisticated attacks are on the rise. And a couple of the examples that I've shown here, both TLS and EOP, these were attacks that were done in the 2017 and 2018 timeframe by some academics at TU Berlin. In this case, the TLS example specifically, they used a laser to probe into a 20 nanometer integrated circuit and be able to extract out the data that that integrated circuit was actually processing. And they did that without any physical modification to the device. No physical modification 6 years ago. The other one is that these emerging sensing capabilities, and I give you 3 different references here. In this case, you could combine all of these attacks into kind of a certain attack vector where what an adversary is doing is they're using circuits inside of the integrated circuit to detect and sense what other circuits inside of that same integrated circuit is doing. And that's really important when we start to think about some of the emerging requirements and architectures like multi-tenancy. So that's a great segue into the next quadrant. If we talk about multi-tenancy, last year at our security working groups, we polled all of our customers and we asked them, how many of you actually have designed and fielded a system using multi-tenancy? And then we also asked them, how many of you expect to be fielding systems like this in the future? And while we had a very small percentage of customers actually designing and fielding systems using multi-tenancy architectures, today, we had a very large percentage of them say that that's something they were going to have to do in the future. So the days of booting securely and then not worrying too much about isolation and access control inside of your integrated circuit are pretty much over. We start looking at confidential compute. So here we're not just worried about protecting data at rest anymore. We're talking about protecting data in transit and while it's operating. And that leads to many different things, like, for example, now I need to encrypt my interfaces, PCIe, Ethernet, the memory controller. When we stop and think about how computing is moving to the edge, and we go back to the conversation we just had around who our adversary is and what their capability is, I need to start asking the question, does my adversary have close physical access to the device? And if the adversary does, I now have a whole new set of attacks I need to worry about, like side channel, DPA. When you put all of this together, you see there's a lot of circuitry being put into these devices to address security. That increased die size, which increased cost. That increased static and dynamic power. And I know all of you in this room love to get that bill every single month to pay your insurance for automobile and home. No one wants to pay for something that may or may not happen. And that's the same with security. So it's very, very difficult to monetize. Think about standards. You know, a couple of years ago, there was no foundational standard for the automotive industry when it came to security, even though our automobiles are full of electronics. Fast forward today, now we get ISO 21434, we get J3101. In the industrial control systems, we have 62443. In data center, we're dealing with Open Compute Project, PCIe IDE, and most recently TDES. But even Common Criteria now has a new protection profile that's very much focused at SOCs. It's our job as a commercial manufacturer to kind of aggregate all of that and synthesize it and turn it into the lowest common denominator so we can maximize our ROI and therefore reduce the cost to the customer. But that also means we have to get rid of those requirements on the fringes, something that's very unique to a market, and that can be very difficult to do. And then finally, just the fact of being in the commercial industry makes us more of a target. Let me state it a different way. If I were to build and ship 10,000 parts total, ever, that's a very different attack profile than if I'm building 100,000 devices per month. We get 18 to 24 months to design in the security and we're done. At that time, that's when the adversary really starts to work in earnest. And they get to attack forever with a lot of devices that are very easily accessible. So my hope is here today, by going through this quad chart, you can get to see some of the challenges that we face as security becomes ubiquitous. Thank you very much.